right, our next example in the quadratic equations here, or quadratic formula for solving a polynomial equation of second degree, involves the fact that we have to have an equation in standard form before we can solve it. It's just like solving it with factoring. It needs to be in standard form. So I'm going to start by taking everything to the one side, and I do want my x squared to remain positive. It's just easier to deal with, even though I'm not factoring. So I'm going to take these to the right side. So 0 is equal to x squared minus 2x minus 7. And then from there, what I want to do is I want to pick off my a, b, and c. So my leading coefficient is 1. That's my a. The coefficient of the x term is a negative 2. That's b. And the constant is negative 7. And so that's my c. So now I'm going to form the solutions, the x's, right, by saying the opposite of whatever b is, the opposite of the negative 2, plus or minus the square root of whatever my b is, negative 2 squared, minus 4 times whatever my a is, that's 1, times whatever my c is, that's negative 7. And this is all over 2 times whatever my a is. So now we have x is equal to 2 plus or minus, and that's the square root of negative 2 times negative 2, which is a positive 4, and a negative times a negative, which is a positive, and 7 times 4, which is 28. So this is the square root of 32. Now later on, in a second algebra class, we'll learn how to simplify the square root of 32, but for now we're just going to leave it alone, and then this is all over 2. And that's about as good as it gets. This we could answer as our final answer, just like that. There is no canceling in addition. The 2's do not cancel. You can't write 1 plus or minus the square root of 32. Or if it makes you more comfortable, you could actually write these as two separate answers, right? 2 plus the square root of 32 all over 2. No, it is not 1 plus or minus the square root of 32. That is not correct. And then you could say, or it is 2 minus the square root of 32 all over 2. And those would be our two possibilities. But this is usually the accepted way of writing it, is just as one term. All right, now looking at our next one, I want to do this one because this doesn't have a leading coefficient of 1. So we have a this time, our leading coefficient is 9, and our b, the coefficient of the x, is a negative 6, and our c, the constant, is a negative 8. So we're going to substitute this in, so my x is equal to the opposite of whatever b is, and then plus or minus, and then the square root of, and we have our minus 6 squared minus 4 times our a, which is 9, times our c, which is a negative 8, and then this is all over 2 times 9. So we'll simplify this down. Opposite of negative 6 is positive 6, plus or minus the square root of, and 6 times 6, negative 6 times negative 6, positive 36, negative and negative make a positive, and we have 32 times 9, which is 8, carry the 1, 288, and 288 plus 36 is going to give us, plus 36 here, is going to give us 4, and carry the 1, so that would be 12, 324, all over 18, and then 6 plus or minus, and the square root of 324, that's actually an integer, it's 18. And so we have this. Now the thing that you need to remember is there's no canceling, right? No canceling there. We have therefore that x is either equal to 6 plus 18, all divided by 18, and the other option, the or, x is equal to 6 minus 18, all over 18. And so 6 plus 18 gives us 24, and those are 24 eighteenths. And here x is equal to a negative 12 eighteenths, and then we would reduce those, and I'm going to run out of time, but reduce them, and so we